The chapter objectives are to explain what a motor behavior researcher does, present the goals of motor behavior, including motor learning, motor control, and motor development, explain the research process used by scholars in motor behavior, and present some of the principles of motor learning, motor control, and motor development. The goals of motor behavior are to understand how motor skills are learned, how processes such as feedback and practice improve learning and performance of skills, and how response selection and execution become more efficient and effective. To understand how motor skills are controlled, how the mechanisms in response selection and execution control movement, and how environmental and individual factors affect mechanisms of response selection and execution. To understand how the learning and control of motor skills change across the lifespan, improving in youth and deteriorating with aging. There are three subdisciplines of the discipline: motor learning, which is the acquisition of skilled movements as a result of practice; motor control, which is the neural, physical, and behavioral aspects of movement; and motor development, the developmental view of motor learning and motor control across a lifespan. Contrasting motor learning and motor control is demonstrated through a shift from learning a skill versus automatic skill. Motor control is essential for every movement from poorly skilled to well-skilled, and motor learning is responsible for shift to well-skilled. Motor behavior is important because the study of how motor skills are learned, controlled, and developed across the lifespan offer applications that focus on the what, how, and how much to practice. It guides us in providing better situations for learning and practice, including the selection of effective cues and feedback, and is valuable to performers and those who teach motor skills, e.g. physical education teachers, adapted physical educators, gerontologists, physical therapists, and coaches. Motor behaviorists work at colleges and universities where they teach motor behavior or related courses. They do research or service. Other research facilities, including hospital, industry, and military, are other sites for motor behaviorists where they do research with applications related to the setting that they're in and writing grants. Motor movements beyond sport are demonstrated through things like babies learning to use a fork and spoon, dentists learning to control a drill while looking in a mirror, surgeons controlling a scalpel, microsurgeons using laser, children learning to ride a bicycle or to roller skate, teenagers learning to drive, dancers performing choreographed movements, pilots learning to control an airplane, or children learning to control a pencil or type on a keyboard. 5 major themes have persisted in motor behavior research. Number 1, the knowledge of results or feedback. Number 2, distribution of practice. Number 3, transfer of training. Number 4, retention. And number 5, individual differences. The history of motor behavior began in the late 1800s, where motor skills were used to understand cognition and neural control. There was a surge of great research interest during World War II. And between the 1940s and 1960s, names such as Glasgow, Rarick, and Espinage did research focused on how children acquire motor skills. In the 1960s, memory drum theory was introduced by Franklin Henry, and motor behavior was identified as a subdiscipline of kinesiology. From the 1970s to the present, the influence of growth and maturation on motor performance has been an area of interest, as has developmental patterns of fundamental movements. Research methods for motor behavior include experimental design studies that study the early stages of learning, also studying expert performance, measuring movements, movement task characteristics, and measuring learning and transfer. The idea of a novel learning task is that to ensure no participant has tried the task before. Tasks tend to be simple. They allow us to study improvement and how movements are learned. However, novel learning tasks do limit what researchers can learn, as this approach studies the outcome of the movement or the product rather than the nature of the movement or the process. and novel learning experiments are not helpful for physical activity tasks in which performers have had many trials. The alternative to novel tasks is to study expert performers and ask questions such as, what do expert performers do during practice and competition, and how does it differ from novices? In that area, we can look at decision-making, skill, and game performance variables. You can also explore knowledge and skills of sport that are highly specific to that sport, and information that helps us understand how learning occurs across many other skills. The overview of knowledge and motor behavior includes information processing, which is a concept formed to help scientists understand how the central nervous system works, conceptualizes the brain as a computer or a master controller, and explores how commands are sent from the brain through the spinal cord, which reduces the complexity of information for the muscles and muscle groups. The goal of motor behavior is to explain response selection and response execution. In looking at the three different areas, we will begin with motor learning, whose goal is to understand the role of practice, feedback, and individual differences. Before practice, goal setting, instructions, modeling, and mental practice. During practice, scheduling practice and context of practice. And practice is a necessary but not sufficient condition for learning, and practice, the results of which are known, makes perfect. Skill acquisition variables versus performance variables. Motor control looks at how motor programs are proposed memory mechanisms that allow movements to be controlled. As motor programs are developed, they become more automatic, allowing the performer to concentrate on the use of the movement in performance situations. And also, the idea of schema theory comes from motor programming. Dynamical systems theory has challenged the motor program theory, in such that dynamical systems theorists believe that a more direct link, like a coordinating structure, exists between perception and action, bypassing the need for motor programs. Which theory, motor program or dynamical systems, more accurately represents the process of motor control? How well does each explain motor learning and the development of motor expertise? You could help determine the answer if you pursue motor behavior research at a higher level. The importance of motor control is clear for professionals in physical education, physical therapy, or athletic training. Motor control is often not intuitive and therefore easily misunderstood. Motor area controls of study include degrees of freedom or coordination of movement, motor equivalency, the serial order of movements, perceptual integration during movement, and skill acquisition. In the area of developmental motor learning and control, the goal is to understand skill acquisition across the lifespan. The two major principles of motor development are that children are not miniature adults and that children are more alike than different. Topics studied in this area include developmental changes in the mechanics of movement, lifespan development, experience, changing neuromuscular systems across the lifespan, and growth and gender in the development of overhand throwing.